So density is mass over volume. So the unit for mass, right? The SI unit is kg, volume is meter cube. So it will be kg per meter cube. Can you guys see that? Or sometimes it will be given in like gram and cm cube. Then this will be gram per cm cube. But the SI unit is the highlighted one. SI unit means the unit that is set by the International Scientists Association. So what does this mean? Because every country, right, you have different unit. Later China work out something, oh, I got this answer. Then the other scientists want to share the data. And then this fella calculate in km, that fella calculate in millimeter, that fella in cm, that fella in inches. Then how are they going to compare the data? They're going to like do a lot of conversion. Very mafan ma. So they say, okay, everyone use the standardized unit. We call the SI unit. All right. So the SI unit is very important for you guys. You need to know all the quantities with the SI unit. Okay, now after we already know what's density equal mass over volume, we're going to talk about the relationship between density and volume. A common misunderstanding here is that students normally, they will thought that density is equals to mass. Means, oh, if the mass is very big, the density is very high. No, density does not relate to mass one. How do I say so? Now, density is referring how close the object are in a volume. So for example, today in this room, just imagine in this room, I got same room on the other side. The first room got only 3 students in the class. But on the second room, there's 5 students in the class. So let's say each student is 1 kg. And the volume of the room is 1 meter cube. So look at the density here will be 3 over 1. The density here will be 5 over 1. So this density will be 3 kg per every meter cube. This density will be 5 kg per meter cube. Okay, you'll be wondering, teacher, why you write P? Guys, forget to write for you guys. The symbol for density is rho equals mass over volume. This read as rho, stand for density. It's a curved P, not a P. Don't write P. It's like a Greek word like this. This is rho. Understand? So rho equals to mass over volume. Okay. Now, then we look at this. Teacher, okay, this room got this room got this. So in this room, there are 3 kg per 1 meter cube. In this room, there are 5 kg per meter cube. So can we say that the density of here, this density is higher than here. So this have lower density. So guys, looking at this one, if your density is high, there are 5 kg people inside. So relatively, this one will be more heavier. Can you guys understand? So you cannot say, teacher, can we say high density is heavier? No, you cannot say that. Not necessary one. You get what I mean? Not. Because why? For example, today, for this box, I enlarge to become volume is 2 meter cube. Now, when I enlarge, there are more people inside. So there are 6 people inside. So you calculate the density is 6 out of 2. The density is 3 kg per meter cube. So the density is 3. But what is the total mass of this fella? The mass of this fella is 6 kg. It's heavier than this. See that or not? So you cannot say, teacher, less density means less mass. No, less density does not mean less mass. You get what I mean or not? The density could be low, but if let's say the shape is big, then it's more heavier than the one that is having high density. Okay? So what I want you guys to understand here is that just remember your density is referring how close the particles are in a certain volume. If there's many particles packed together, the density is high. If there are many particles loose out from each other, the density is low. So as we learned from year 7, year 8, year 9, right? High density will sink, low density will float in the water. Okay, so that's the idea. How close the particles are, that's called the relationship. Then teacher, what if now I got bigger volume? See, if let's say I got small volume, this small volume got maybe 2 particles. And now I enlarge this room. I make the room larger, but I did not add the student number. The student is still the same. There are 2 people inside. So when your volume is small, the density is high. But when your volume bigger, the particles did not change, then your density will drop. So it's very simple that a piece of paper, don't want to use a piece of paper. Maybe we use, maybe I use a piece of paper, I fold a box like this. This box will be very light, correct or not? Very less than, and it could float on water. But today, I squash the paper into very, very small piece of thing. the paper will be very high density because the same particles, but the volume is much smaller than what I folded here. You guys get what I mean or not? Okay, can I? So that's the idea, yeah? So your volume and your density is inversely proportional. So that's your relationship between density and volume. So if today I want to do an experiment to find the volume with irregular shape. Okay, first, I'm going to talk about regular shape first. So for regular shape, let's say I want to find the density of like a cuboid. I want to find the density of this cuboid. How do I find? First, you must know density is mass over volume. So we need the mass of this cuboid. How can we get the mass? Place it on weighing balance to obtain mass. Okay, so we put it on weighing balance, we obtain the mass already. Then how can we get the volume? Oh, the volume of a cuboid is length times width times height. Based on maths formula, we'll be able to tell. Then how do we get density? Put in the formula, density is mass divided by volume. You got mass, you got volume, very easy to find. Regular shape is very simple. But what if today you are measuring like irregular shape? Maybe today I want to measure the density of like Jingwei. Jingwei, can I take you an example or not? Okay, I want to measure the statue of Jingwei lah. So let's say this is Jingwei. Wow, if I want to get the density of Jingwei, the problem is I need the mass. Okay, you say, okay, you can teacher, no problem. So we place it on weighing scale or weighing balance to obtain mass. So we can get the mass of this person. But today, density is mass over volume. Okay, you got your mass already. How can we get the volume of a human? It's not a regular shape. What do you guys think? Xingxuan, would you like to give it a try? How do we obtain the volume of this fella? So what we do is that we can use a displacement method to get the volume. Wow, sounds very atas, but actually very simple only. So this displacement method, discovered by our Archimedes, displacement method, where I'll prepare a cylinder with some volume. I read volume 1, and I throw Jingwei statue inside. So that's volume 2. And to get the volume of Jingwei, we just use volume 2 minus volume 1. Can or not? So from displacement method, I'll be able to obtain the volume of the statue already, lor. But guys, there's also another method. We can use your Eureka can. Your Eureka can is something like this one. There's a hole connected to your, this is a measuring cylinder. So there'll be some liquid here lah. So what happened is that when they have liquid here, they put Jingwei in, this water will overflow to here. Then the volume here is the volume that you are finding. Can or not? Okay, that will be the volume of you finding. So there are two methods. For me, I prefer displacement method lah. More things to write in exam. So from here, volume obtained. Then the last step, density equals mass over volume. Done. Because you obtain the mass and you have the volume. Is that okay for all of you? Can I follow? In exam, they'll ask you to describe 4 marks. Describe how you obtain the mass or the density of an irregular shape. Or maybe they tell you a rock. How are you going to measure the density of a rock? Rock is irregular shape. So mass of the rock can be obtained by putting on weighing scale. But to find the volume of the rock, you use the displacement method. First, prepare a certain volume of water in a cylinder. Immerse the rock completely. You must put the rock completely inside the water. And then read the second reading of the volume. So the difference in volume will be the volume of the rock. Then apply density equals mass over volume to get the density of the rock. What if today they want to measure a cork? You guys know what cork is? C-O-R-K. You guys don't think of other thing, okay? I want to measure the cork. The problem is cork. Okay, I don't want to pronounce it just this thing now. Okay, this thing you're going to put in the water to get the volume, but this thing is going to float in the water. How are you supposed to get the volume of? What you do? You tie with a rock first, so it sinks under the water. And then the volume here, let's say this volume, I use the volume minus the volume of the rock plus water. Get what I mean? Then I can get the volume already. All right, because the cork gonna float on water, it's impossible for us to measure the volume. So we tie it with the rock. We minus the volume of the rock, and then the difference in volume will be the volume of the cork.